Alright, so in this video, I want to address a few topics. I want to address, let's see, theoretical yield, percent yield, limiting reagents. There's a few things we need to talk about in this video today. And I'm hoping I can address all of those just by, again, doing a practice problem. So today we're going to be considering the following reaction here between propane and oxygen to produce some water and some carbon dioxide. Now here I have the molar masses of all of these molecules and compounds involved in the reaction. And let's do this. Let's say at the start of this reaction we had 58.065 grams of your propane. And let's say we had 88.916 grams of oxygen. Now, based off of these two values, can we figure out which of them is the limiting reagent? That is propane going to be the limiting reagent, or is oxygen going to be the limiting reagent? To figure that out, here's what we need to do. Well, here's what I'm going to do at least. Let's say with propane, what we're going to do is we're going to take the grams of propane and we're going to convert to moles of propane using the molar mass of propane. Then using reaction stoichiometry, we can go from moles of propane to, let's say, moles of carbon dioxide. And then we can go from moles of carbon dioxide to grams of carbon dioxide using molar mass of CO2 as a conversion factor. So whatever we get for the grams of CO2, we'll write that number down. And then we'll repeat that whole process for oxygen. So we'll take the grams of oxygen, and using the molar mass of oxygen, we'll go from grams to moles of oxygen. And then using reaction stoichiometry, we'll go from moles of oxygen to moles of CO2. And then we'll go from moles of CO2 to grams of CO2, again using molar mass as a conversion factor. After we do that, we'll have grams of CO2 that should be able to be produced from this much propane. And we'll also have grams of CO2 that should be able to be produced from this many grams of oxygen. Whichever one of these values comes out to be smaller, that is, whichever grams of CO2 comes out to be smaller here, that will tell us which of these two is our limiting reagent. Might make more sense to just see it, to work through it, so why don't we go ahead and get started. So, let's see, we'll start with blue. We'll take this many grams of our propane, so 58.065 grams of C3H8, and we'll use the molar mass here to go from grams to moles of propane. So 44.096 grams of C3H8 to 1 mole of C3H8. Notice that we have grams of propane in the numerator over here and in the denominator over here, so our units will cancel out, right? Okay, so now we're going to go from moles of propane to moles of CO2, and we're going to use reaction stoichiometry to do that. It looks to me that for every 1 mole of propane, you're going to liberate 3 moles of CO2. So let's write that down in our next conversion step. 1 mole of C3H8 to 3 moles of CO2. And again, we can cancel out our units here. So let's go ahead and do that. Alright, so now we're going to go from moles of CO2 to grams of CO2, just using the molar mass here as a conversion factor. So then we can say for 1 mole of CO2, we have 44.01 grams of CO2. So 1 mole of CO2, 44.01 grams of CO2. Okay, we have moles of CO2 in the numerator here. It's in the denominator over here, so we can actually cancel that out. Now, once we punch this into the calculator, we should be able to figure out the grams of CO2 produced given this much propane here, right? Now, before I actually punch this into the calculator, I'm going to go ahead and repeat this whole process given this much oxygen. So, if we have 88.916 grams of oxygen, we're going to start with that grams of oxygen, and we're going to go to moles of oxygen, just like we did up here for our propane. So, using the molar mass here as a conversion factor, looks like we have 32.00 grams of O2 for 1 mole of O2. We have grams of oxygen in the numerator. We have grams of oxygen in the denominator. They'll cancel out. And now we can go from moles of oxygen to moles of carbon dioxide. Very, very similar to what we did up here with propane, right? Well, the reaction stoichiometry this time looks like it's a 5-to-3 relationship. So we'll say for every 5 moles of O2, 5 moles of O2, we'll get 3 moles of CO2. So 3 moles of CO2. We have moles of O2 in the numerator. We have moles of O2 in the denominator. That will cancel out. Last step, we'll go from moles of CO2 to grams of CO2 using the molar mass of CO2 as a conversion factor. So then we'll say for every 1 mole of CO2, we'll get 44.01 grams of CO2. All right, so in both of these cases, what we did was we started out with the mass of our starting material. In this case, we started out with the initial mass of propane. Here, we started out with the initial mass of oxygen. And then going from our second step here, we converted to moles of our propane, or moles of our oxygen, our other starting reagent, right? Next, we converted from moles of our reactant to moles of CO2. Did that for both of our reactants here, right? And then once we were in terms of moles of CO2, we went to grams of CO2. So, let's go ahead and punch this into the calculator. Let's see what we get. We'll punch this into the calculator and we'll see what we get. Oh, I need to cross out my units here. Moles of CO2, moles of CO2. All right, so let's figure out how many grams of CO2 we could produce given this many grams of our propane. So we'll take 58.065, we'll multiply by 1, multiply by 3, multiply by 44.01. Now we'll divide by 44.096. We'll divide by 1, and we'll divide by 1. And assuming I know how to use one of these things, right, I've had difficulties with these guys in the past, we should be able to produce 173.9 grams of CO2. So, given this much of our propane, right, given 58.065 grams of propane, assuming all of that reacts, we should be able to produce this many grams of CO2. What about oxygen? Let's go ahead and figure that out. We'll take 88.916 and we'll multiply that by 1 times 3 times 44.01, and we'll divide by 32.00. We'll divide by 5. We'll divide by 1. And again, assuming I did my math correctly with this calculator here, we should be able to produce 73.37 grams of CO2. All right, we've just figured out a few things here, actually. So given this much propane initially and this much oxygen initially, what we found out is that our limiting reagent is actually going to be oxygen, right? Because we started out with our initial amounts of reagents, and we converted to how much product we could make for both of them. And we figured out that with oxygen, we can only make this much product, right? What this means is that oxygen is our limiting reagent. So I'm going to go ahead and write that up here above oxygen. Limiting reagent. Not only did we figure out that oxygen is our limiting reagent, just based off of the fact that it limits sort of how much product we can make, but we also figured out the theoretical yield of our product. So, theoretical yield of CO2 is going to be 73.37 grams. Right? In theory, if all of this oxygen reacts, and goes to completion, we should, in theory, be able to produce this many grams of our carbon dioxide. But why don't we calculate the percent yield now based off of our theoretical yield? So let me erase some of this and I can make some space. I want to keep these numbers up here because we're not quite done with them yet. So let me just section this off. Right, so this was the amount of CO2 you could produce given this much C3H8. And this was the amount of CO2 you could produce given this much oxygen. We'll talk more about this in a second while I'm keeping those values up. But now let's figure out the percent yield of CO2. What is the equation for percent yield? Well, percent yield can be calculated in the following way. You're going to take your actual yield and you're going to divide by your theoretical yield. And then whatever that ratio is, you're going to multiply that by 100%. So if this is our theoretical yield, why don't we say we have an actual yield of, let's say our actual yield here was 59, I guess, 0.86 grams. Based off of your actual yield and the theoretical yield, what will the percent yield come out to? Well, percent yield will equal our actual yield, which is this 59.86 grams. 59.86 grams. And that's grams of CO2, right? This is how much CO2 we actually produced. So it's going to be 59.86 grams of CO2, our actual yield, divided by our theoretical yield of 73.37 grams. So 73.37 grams of CO2. And we're going to multiply that by 100%. Notice we have grams of CO2 in the numerator here. We have grams of CO2 in the denominator. Those units are going to cancel out, right? So let me grab my calculator and we'll figure out what our percent yield actually was. So 59.86 divided by 73.37 times 100. That should give us a percent yield of 81.59%. Awesome. So we figured out a lot of things in this video, right? Given these initial masses of our reagents, we figured out how much product we could make, right? Given this much propane, we figured that we could produce this much CO2. Given this much oxygen, we figured that we could produce this much CO2. Because this value was smaller than this value, we knew that O2 was our limiting reagent. Also, we figured out that this number here represented our theoretical yield. That is, in theory, if all of this oxygen reacted, all of it reacted, we should be able to produce this much carbon dioxide. So we figured out O2 was the limiting reagent, and we figured out our theoretical yield here, right? And then I said that the actual yield was this for CO2. So then given our actual yield and our theoretical yield, we could calculate the percent yield, right? Percent yield is your actual yield divided by your theoretical yield times 100%. And in this case, we figured out that our percent yield was 81.59%. All right, so we talked about a lot here, right? Now, I kept these numbers up here for a reason. What was that exactly? Oh, if this is our limiting reagent, this is the reagent we had in excess, right? We had an excess amount of propane. Some of our propane reacted to give us our product, but not all of it. So my question for you is this. How much excess propane did we have? I'm not going to actually work that out, but I will put the answer in the description. How can you go about figuring out the excess? I'm going to let you guys do this on your own, but basically what you can do is this. You can take the theoretical amount of CO2 produced, and then you can back calculate how much propane actually reacted. Whatever that number comes out to, you could subtract that from the initial amount of propane you had. Whatever that difference is, that'll tell you how much propane you had in excess. All right, folks, there you have it. We talked about theoretical yield, percent yield, limiting reagent. I'm going to let you guys figure out the excess reagent here, although I will post the answer in the description. If you have any questions about anything I did in this video, or if I made some sort of math or calculation error, let me know. I just made this problem up like 5 minutes before the video was shot. So anyway, thanks for watching. Stay tuned because there's more where this came from. And as always, take care.